Alright, here's a quick video on making a Arduino Uno Shield. So this is going to be a fairly simple circuit. Actually, the schematic's only going to be the 4 headers and then a bunch of nodes and labels. Then we're going to focus much more on actually making a custom size and shape circuit board. So the emphasis is going to be more on the PCB and the dimensioning things to specific desired dimensions. And so it's going to be, I think it might be a short video. So this is something that you can do to build your own custom Arduino Shield. So you can put anything you want on there, really. You could put anything from motor drivers. You can make your own LED display. Really, your imagination and somewhat the capabilities of the Arduino Uno are the only limitations. So I've opened up Circuitmaker here, and this is just the normal home page. So I'm going to start with add a new project. And of course we name it. So we're going to call it Arduino Uno. And we'll just call it Shield. Click save. And I'm not going to add anything. I don't have any photos. I don't care about making a description right now. So we're just going to click save. We're going to go up, start with a new schematic, and we're going to call it Arduino Uno Shield. And we're going to open up a PCB. Come on. Add a new PCB. And let's go back to, man, a little slow today. All right, so our custom shield is going to be just the 4 header pins. So there's 2 8-pin headers, a 10-pin header, and a 6-pin header. One of the things that you might find out about doing the searches for an octal part is, at least I find it a little difficult to find kind of exactly what I want. So I might do a search for, like, let's just say 6-pin header. And it's going to bring up all kinds of stuff that I don't really need. So, like, what I want is something like this. Okay, this is actually a bad example of it not being able to find what I want. But let's say I actually don't like this particular silk screen or this footprint. I don't know, for whatever reason. Like in the case of the Arduino, I want to make sure that the 4 of them roughly match. But a lot of times it'll give you all kinds of stuff you don't want. And like this part, it's technically 6 pins, but it's not what I want. Worth, and here again, this is a surface mount component. That's not what I want. Here's a Molex, but I think this one's actually a 0.2 inch pitch. So there's actually 0.2 inch between the pins, and we want a 0.1 inch, which is the standard pin header. And so a lot of times what's sometimes helpful is actually if you actually know the part you want. So in this case, I've actually gone through and found the part I actually want, the part that works. So I'm going to type it in, 5-146-278-6, I think. Nope, that's not it. Seriously? Okay. So, finally got it right. Apparently you have to have all your spaces and crap in the right place. Anyway. Okay, so this is the 6-pin header. So I'm going to line this up. So this is going to be like the top left of the Arduino. This is where the barrel jack's going to be, the USB, and the headers are on the side. So I'm going to line it up so that it looks like how it should. So this is actually going to be the bottom left. And we're going to hit tab. So I actually want it to face in. So scroll that down, click mirrored. Okay. And click that. I only want one of those. So we can actually go through and see. I'm going to press and hold the shift button down. And then hold and press the right mouse button. And I can just kind of move it around. So this is what the 3D model will look like. It's not the best, but it's certainly not the worst. Just click OK. All right, next thing I want to find is the 8-pin header. So that is the Molex 22-03-2081. See, that one's so much more cooperative. And you can see this actually brings up 3 other ones, but this, so you can actually click on this. Well, we already clicked on this one. You can see it's got a schematic, and it's also got the footprint for it. And if I click on one of the other ones, there's nothing down there. There's nothing down there. And there's nothing down there. So obviously if you clicked on that, you can't even place it. So we're just going to go ahead and click place. And I'm going to put this one here. And again, I want to mirror it because the 8-pin is also on the other side. So mirror. And I'll just place that one there. So here you can see this one's it's a little bit better of a 3D model, but it's close enough. And I'll press escape. Now we just got the 10-pin header. So this is also going to be a Molex 22-28-4100. And that one comes up. So we're going to place that and right there. And we can check out this 3D model. So that one has a little bit better resolution, a little bit more better detail. But if I was going to be a stickler, these would be nice if they were actually colored accurately, like that was black and this was like a silvery or a copper. But beggars can't be choosers. You can actually go in and change the model. You can actually put something in if you have a part that you want, but there's no 3D model. You can actually go in and modify the part, edit the part. You can make yours from scratch, but I think we'll do that in another video. All right, so this is going to be my, I guess call it the top left-ish header. So this is going to start with the first one's not connected, and then the rest is going to be the IO ref, reset, etc. And this is the analog inputs. This is the TX and RX, and then D2 through D13. And then the ground, A reference, and the SDA and SCL. So we're just going to go through and going to add a couple things. So first off, I want to point out, you can see there's this one is called J question mark. This one's called J question mark. This one's called J question mark. So these are the designators, and this is this kind of little red squiggly line. You can kind of barely tell it here and there, but this is also telling you that they're all named the same thing. So you can go in there. You can click on it and change it one at a time, or you can actually go up to, let's see, I think it's under Tools, do Annotate and Annotate Schematics Quietly. So they need to be updated, so we'll click Yes. And then it goes 1, 2, 3. And if you don't like the way that's numbered, you can actually go back and let's see, here you can actually change the way that it's designates it. So it actually went 1, 2, and there wasn't anything over there. It went 3. So if we actually wanted to do, let's see, down then across. So 1, 2, 3, 4. That just kind of makes sense to me. We can actually click OK. And I think we should do it again. Nope, just kidding. There we go. So 1. Oh man, it made a liar out of me. So it should go 1. Skip it. 3, 4. Anyway, you can always go in and change it manually too. Maybe. We'll just change that to J2. Keep that J3. J4. All right. So now we just need to go through and add a bunch of net labels. So I'm actually going to first go through and add some wires manually. Actually, let's draw this out a little bit more. So these are the 2 grounds. So on this side it has the VN, then it has 2 grounds, then it's going to have the 5 volt and 3.3 volt So for the 5 volt, I want to bring in the, so I'm going to put in some power ports. So here's the positive 5 volts. And so if anybody, so that's just a power port, and I guess the it's just choosing to be ground. But we can actually go in and label that. So we're going to do 5 volts. So this is a global variable, kind of like in programming. So if I use this power port on another schematic in the same design, then this is going to be logically connected. So if I can have a bunch of 5 volt power ports scattered throughout, it'll all be connected. So instead of actually drawing wires all over the place, you can use these global variables. So we're going to actually, let's toss in another one. And 3.3 volts goes on top. So 3.3 volts. Yeah, let's drag that down, make that a little bit cleaner. And there's also ground on the other side. 1, 2, 3, 4 down. And so shortcut for ground is Z. And shortcut for wire is W. Oops. And we also want to add wires over here. We'll see why in a second. And every once in a while, it will just kind of go crazy on you. For some reason, it does that when putting in wires. So I'm just going to put in some net labels. So one of the fun things is you can actually, so before I actually attach this to anything, I'm going to press tab. Now I'm going to type a 0 and to attach to that. Then you'll see it automatically increments the number. So I don't have to go through every single one. All right, so we're going to add a couple more net labels up here. So the first one's not connected. I'm going to hit tab, and this one's called IO ref. It goes to pin 2. The next one, this one is reset. And I should get connect pin number 3. And it says pin 4, pin 5, pin 6, and 7 are ground. Pin 8, and shortcut for net label is N. And before I attach it, I want to change this to VN. Attach that. Now for the other side, before Circuitmaker just started losing its mind, since you can see, it has kind of like a left justification for where I want to connect it. So if I just went in here and attached that, the word might just kind of bleed into the part itself, and it just looks less. It's more difficult to see what things are. So I like to just draw wires out, and so it has something to basically sit on. So this is the entirety of our hardware for the Arduino Shield. So make sure we go up and click save, just because Circuitmaker can be glitchy and we don't want to get halfway through a project and it just kind of glitches out on us. So I want to go up here, I want to compile it. So this is basically telling Circuitmaker all the net labels. It's basically just processing it. So I'm going to go to my schematic. Now I don't want to import the parts. Usually what we do is you just go up here and you import the changes to grab all the parts, but we don't want to do that. We want to actually build a custom size and shape board. So one of the things I first want to do is that, so I've got the dimensions, I just found it off the internet. It's fairly standard, but I actually went through and measured a bunch of the locations for the holes, or rather the header pins, just to confirm the dimensions. So we want to make sure that everything is in the right place. So when we actually get the right parts and solder the female headers that have the long male headers on the bottom to connect to the Arduino underneath, that everything will actually line up nicely. So one of the first things I want to do is I want to go up here and change this to 100 mil. So every one of these little lines, so we can actually even zoom in closer. So I'm pressing and holding the control and scrolling in. Every one of these smaller demarcations is 100 mil. So this is the snap grid. And so each one of these like heavier ones is actually 500 mils, so half an inch. So the Arduino board's got kind of a funky shape. It's roughly rectangular. It's got a couple little rounded corners, and then it's kind of got the funny edge on the right. If the we're going to put the barrel jack on this side. Well, we're not actually going to put a barrel jack, but the barrel jack will be over here. The USB is going to be here, and then your reset button's up here. Actually, technically speaking, it's up here. Let's go with the dimensions. So in order to, so we basically want to create a shape. We want to create the outline, and so we're actually going to do that on the outline layer. Now, other videos you see me actually doing that kind of as the last step, but here we're going to do it as the first step. And we're actually going to use that shape. We're going to tell the software to define the shape of the board based on the outline layer. And so we want to go and we want to draw a line. So the first line, we're going to start off here, start in this corner. We're going to go up, that's 1 inch, that's 2 inches. We want to go up 2.1 inches, so right there. And then we want to go over, so the whole thing is 2.7 inch. And so if we have this little bump out over here, there's like this little corner, it has a little bit of an angle, and then it'll drop down straight, and then it bumps out, and then drops down straight, and that kind of, we'll call it a squiggly. So the whole thing is 2.7. So that first bump out is 0.1, and this little corner, this little nib taken out is actually 0.05. So we want to take 2.7 minus what did I say? 0.15. So it's going to be 2.55. So here we've gone 2. We actually just go 2.5. And then we want to right click to escape out of that. Then we're going to actually change it down to, we're going to change it to 50 mil. So this will give us our 0.05. And then I'm going to go back up and draw a line. And then you can see the resolution changed. I want to go to that 0.5. Now I want to go down at that fun angle. And I want to go down by 0.45. So I want to go down, what is that, 9? 9 times 0.05 is 0.45. So 1, and then 6, 7, 8, 9. And then it goes off for 0.1 inch at a 45-degree angle. We click that, and then we'll just stop that. Then we can go back up. We're going to change this back to 100 mil. And we're going to go draw another line. And this is actually, let's actually start back over here. So I want to go 2.6. So there's 1, 2, 2.5, 2.6. So this lines up with this line. Now we go, I'm going to change this to 0.5 or 50. Change that to 50 mils. And then I want to draw a line that goes up by 50 mils. And then that's going to go diagonally for 2. And then all I want to do is connect these. So I do want to go back and do a little bit of editing. Let's actually go and check the dimensions. So we can actually confirm that all these dimensions are correct. So I've written down a bunch of them. So we want to go, so I put it on the dimensions layer. And that's so we're not drawing on the outline layer or the top layer or the bottom layer. And this is something that will get edited out. So this, if I'm right, should be. So we're gonna, let's zoom in a little closer. So this should snap to that. We're gonna left click it, and I guess we're gonna check. We're gonna select that, and zoom back out. So what did I say this should be? 2.55, I think. Oh, I missed. Drats. Do that again. Click, select, drag, select that. Yeah, it's doing it to the wrong side. Jerk. Let's start here. Nope. Well, anyway, so we can, it's just, oh, jerk. Anyway, so we can actually see that this is 2.55. So this is 0.5, and we're getting 2.5. So it keeps wanting to select the same line. So I drew this half line. What I could do, I could just delete that, and we'll go back in and extend that one out. Then we should be able to go back and go to dimensions. We're still on the dimension layer, linear. Click that. Yep. Select that. Select that. There we go. Yeah, we got our 2.55. Now let's measure this line. I got this right, hopefully. So we don't want to go that way. We're going to press spacebar. So that's if it selects the right spot. Nope. It's going to be a pain. So let's see. I actually want to select that one because it's going to be a little bugger. And select. Select that. That's 0.45. Nope, actually, I want to go back in. I want to put a nice little rounded corner here. So I want to go back to arc and arc edge. All right, and I want to see it's going this way. You can press spacebar, have it flip the other way. And this, just move that in. No. And I'm just gonna go ahead and delete that. This might not be the best way to do it, but it'll work. And so we're gonna go in and, bet you I can just start with that. Shut up. We're gonna go ahead and delete that. Yeah, stop yelling at me. Edge. And there we go. Alright, so I'm going to go back and reselect everything. Now I'm only selecting the outline layer and go up to board shape, define from selected objects, and there we go. Just like that, we've got our overall dimensions of the board, the overall outline, and this will be cut out just in the shape of the Arduino Uno. So that's just the overall shape. Now we got to get some holes mounted. Now to grab a hole, we're actually going to use a pad, and we're gonna, before we actually place it, we're gonna hit the tab, and the dimension in mils is 125, which is 1/8 of an inch. And we could change this. That's probably best practice. Tab 125, and let's make this not plated. I want it just to be mounting hole. So plating will be like, it'll have metal on the inside edge of the hole that will connect from one side to the other, but this is just a physical mounting hole. We don't need that. So click that. And I'm just going to put this roughly where it goes. Like, there's one here. There's like one there. There's one here. And then there's one roughly there. Press escape. Now we want to actually dimension these properly. So this one, And there we go. All right. So now we have the physical dimensions of our board. All we need to do is import the parts and place them correctly. Now I'm going to keep the 100 mil spacing for now. I think we need to change it back and forth maybe once or twice. But you can see our overall dimensions are exactly on spec according to what is found on the internet. I've used boards of this dimension before, so I do know that this works. So we're going to go back up, and now we're going to import all the parts from our circuit, or from my schematic. So we open that up, validate changes, execute changes, and all of our parts should be there, and they're colliding with each other, whatever. And so I'm going to move this guy. This is our 10. So this is this guy up here. So this is going to be up here. And this is pin 1, so we can actually zoom in close. So this should be the SCL and SDA. And so we want that going towards the left. We want that to the hole. So highlight that, press spacebar. In theory, pressing and holding down the shift button and then pressing the spacebar should get it to rotate clockwise. But I think that's just one of those, let's just say, features of Circuitmaker that doesn't always work the way it should. Now we want one of the 8 pins, and we want J4. So we're going to grab this guy. And again, pin 1 is D7. So pin 1 is typically, although not necessarily universally, pin 1 is often designated with a square as opposed to a round or even oval. That's just something that's nice. So we're going to rotate that one more time, and we're just going to arbitrarily throw it up there. We're gonna space these out properly in just a bit. Okay, for a second there I thought this was longer than it should be. It would be a pain. And over here, this is pin 1. This should be the not connected. Yep, there's nothing there. The ORF reset, etc., etc. And we want to rotate that, press it 3 times, and just arbitrarily throw it there. And you can do this as you move. Oops, see what I did there? See, I'm moving this, but this one is highlighted. So you can accidentally hit the space bar. Well, you can intentionally hit the space bar and accidentally rotate the wrong piece. So we always want to make sure that we're selecting, or we have highlighted the piece we want to move and not the piece we don't want to move. So we want to make sure, yeah, now we're highlighted. Now if we rotate it while we move, and we'll just arbitrarily throw it. I think that's what it actually does. It goes pretty far down there. And we'll just arbitrarily, and we'll just place it there. So that roughly is where the headers go. But you need to make sure that they're dimensioned properly. So I have used this hole as a reference in reference to this. All right. So that is all of the dimensions that you need to make sure that that this is the standard dimensions and locations for the dimensions for the entire outline. And this is the dimensions for the holes, the size of the holes, the number of pins, the pin headers, the spacing, reference to all of that. So this, I'm very confident, will work in any kind of Arduino Shield. So one of the things we'll want to do is, so that, because I know I do dumb stuff, I want to make sure that this is locked. And actually I want to move the header to the bottom layer. It'll look better in the 3D, I think. Click OK. That was interesting. It changed the, hold on. That fully screwed up. Yep. So it rotated it, so I want rotation to be 0. Then I flip it back. Yep, see it screwed up. That's always one of those little gotchas. Sometimes it doesn't rotate it around from bottom to top. It doesn't just keep all the pins in the same location. So you always want to keep an eye on that. And I don't know, I can't remember if I locked that or not. So bottom layer. Okay, it shouldn't normally be that painful, but for some reason, it just wanted to make things difficult. So let's just go through and make sure that these pins are in fact what they should be, a 5 through a 0. Let's actually look at the physical Arduino. That is the case. And we've got VN, ground, 5, 3.3, reset, ORF, or IRF, and not connected. And if I zoom in, you can actually see there's a little key symbol, so that lets you know that it's locked. And we're going over here. So this is RX/D0. And this is TX, and that starts at D2, 3, 4, 5, 6, 7. Skip a bit. 8, 9, 10, 11, 12, 13. Ground, ARF, SDA, and SCL. All right. So now that's all the dimensions. Let's double check. All right, see, that's got a little buggered up. So this one looks like this one moved. So we need to go back, unlock it, click OK, kind of give it a little wiggle. Not entirely. I think it has something to do with where the center is. Sometimes it just gets a little out of whack. But let's just make sure everything's nice and as exact. 100, 200, 2700, 160, 550, 600, 2550. And this was 50, and then 100. This was 100, this is 50. That's 100, 450. All right. Didn't screw anything else up. Let's that was the wrong one. Cancel. Let's go and relock that. So the idea of locking is, again, so I don't actually grab something and move it out of whack. All right, so we can actually check this on the 3-dimensional layer and see what it looks like. So I hit 3. So we've got some nice holes there. This is the rough shape. And so you press and hold shift, and then right mouse hold and scroll around. So these aren't, I mean, that's interesting. These pins are different length. Huh. Well, anyway, so this is obviously not necessarily ideal. Ideally, you want to get the exact components that we want to use. So we want to get the ones that, that they have the nice long legs, kind of like what this is. We also want the part that has the socket part that sticks up at the side. But for the sake of what we're doing, it was just a pain in the butt to find the exact components, and I just basically gave up. I'm sure it's out there, but so we're just going to go with that for now. So we're going to switch back to the 2-dimensional layer, and all we need to do is actually add in the silk screen. So this is just going to be a whole bunch of text. So I'm going to hit, oh, see, I'm still on the dimension layer, so I'm going to hit escape. I want it to be on the top overlay. So this is the silk screen. So when I hit text, I want to do one thing. I want to press tab. I want to, and this is before I'm placing it. So I want to switch it to true type font. 60 mils is going to be fine. Rotation, I think I want 270. And let's just start with IO ref. No, I wanted 90. Nuts. So let's zoom in so we can see this a little bit bigger. Yeah, so I want the text going the other way. And I'm also going to want to change this to 25 mils. And text, oh, let's do that. So I want to be 90. And IO ref. True type. and click OK. So now the 50 will let me get right in the middle of the pad, and so I can just place that. All I have to do is hit tab and change the text. Of course, I already screwed that up. So we want to put IOREF there because this is not connected. Haha. So let's change that. Tab. Now we want to go to reset. I'm going to change this to 90. TrueType font. So the only time I have to change all these things are after I select where it should go, or after I hit escape rather. And so reset, I'm going to put that so everything will be nice and aligned. So it still has that, still keeps all the same format. I'm going to press and that is how you make an Arduino Uno Shield. So now what you can do with this after the fact is obviously there's nothing actually routed. So what you would do, actually you can go back and you know what, let's just kidding. Let's grab these. We're gonna move these up to here. Grab all that. Yeah, kind of really. Basically what I'm doing is just I want to put these off to the side, and so we can actually go in and we're going to add a polygon around it. So we're just going to basically block it off. And about that. There. Change that to white. Make it transparent. All right, and then we can. So this is basically setting it apart from the rest of your schematic. So this is going to be the built-in stuff you don't want to change. It has all the net labels, all the same ground, 3.3 volts, 5 volts, all that kind of stuff. So these would be all the net labels you would use elsewhere throughout your schematic. And so we're also going to throw in a text string. Now let's put that at the bottom here. Text string. Let's see. Arduino Shield. Yeah, hold on. Arduino Shield headers. Yeah, we can make that a little bit larger font. Text string. I think go with the classic 12. See how big that looks. Yeah, that's good enough. So this is the basically setting up a kind of a template for any other future design that you want to have on a solderless breadboard onto an Arduino Shield. So anybody can actually then, so once I go through and click Save All, and I want to commit project. All right, so now anybody can take the schematic, they can add their own parts, and then if you want to actually connect to the headers, all you would do is use a net label. You know, if you want to connect to D7 and D8 in your own schematic, you would just put in a net label and rename it D7 and D8. So you can actually add in whatever you want, and then you would just do it normally to the PCB. You would add, you would go through and click import changes. Then, assuming you haven't screwed up anything up here, it will import all of the components you've had, and then you would just place and route it. You can actually make a field of solder points. It's basically a field of paths, so you can make your own. Let's say you want to build a data logger, so you can put your own data logger parts on here, and then you can actually put a bunch of basically a prototyping area, and so you can solder your own components on there. Let's say you want to build a relay driver, so you can put on your own relays and run your own traces from all of that. So this is really made as a template. So what you would do, so in the start, you would go to, let's just go to home. And if we go to my projects, so here, you would click on it. Actually, let's just go open it up. And then you would fork it. And so this basically just copies. It just makes a copy. So we'll just create. So now I've just forked my own design. Gotta say that carefully. And so we go into, let's go back. Go back to my projects. Now you can see I've got the Arduino Shield. Now I've got a copy. So one of the things you want to make sure you don't do is screw up your original. Obviously, it wouldn't take you necessarily very long to go back and redo it. But so anytime you build a new circuit, you want to make your own shield, you build it onto a copy. And so anybody can actually go onto this design and make their own copy, and then hop right into making their own Arduino Shield. So I hope everybody finds this helpful.